Welcome to ITSE 1345. At this point, I'd like to kind of go back and kind of recap where we're at. At the very beginning, we talked about the fact that we were going to discuss 15 major items in this course. We talked about 14 of them at this point. And I want to go back and look at how those 14 items interact. Because the last item to talk about is triggers and how you manage that user, which we'll discuss in Chapter 10. Chapter 9 talks about triggers, but understand that a trigger will react to some event, and whatever programs will be turned on by that trigger have to be as pristine and as perfect as can be, because there's very seldom a recourse. In some cases, you actually have a complete backup, so you'll have a snapshot view before you do any modifications. The triggers, as we spoke, take action. So you have to be careful that the program is perfect, because in many cases, once the trigger takes action, there's no recourse. In many cases, before you take significant action with a trigger, you have like a complete backup, so you have a snapshot before you do any changes to it. So we'll discuss that in Chapter 9. Getting back to what I started, that I kind of want to do a recap. One of the first things we talked about was SQL. And we talked about how you have the join. So we began with SQL and the joins, and how significant it is to understand how joins work. So understanding that if you have joins, effectively what you do, if you have table 1, table 2, table 3, and you're going to do a join, what happens is that you actually have a scenario where these two will create a subset, and then this will be parasitic on that subset. So instead of having this scenario, you do one join, which gives you a result, and then the third item will react with this, because this is the outcome of this too. So you're actually having two events. It's a lot easier to take two tables, extract the data that you need, and then run the third table against that subset. That way it's easier to manage. We talked about the block in PL SQL. So we talked about the fact that you have the declare, the begin, the exception, and the end in that respect. And then in this item, you had the named event that developed into the procedures, the function, the package, and the trigger. So those are the four events that are named. We talked about the anonymous. Now, the anonymous scenario is not saved. You can create it and use it, but it's never set aside, because it's never a name. It was never stored. It only works while you're using it. Once you log off, it's gone. So you have the named and the anonymous items. One of the things that this is one of those, you learn by experience. When we're talking about a lot of these items, what you have to be careful with, and I was guilty of it, it's Friday, 3 o'clock, boss comes in and says, I need this report. So you sit there frantically, type on the keyboard, trying to get the supervisor what he needs. But you do it in the anonymous scenario, or you do it in the named scenario. But what happens is that you're in a rush because you got to get out by 5, because you have to go to your child's baseball game, soccer, or whatever. So you're in a hurry. You give the response to the supervisor, so the supervisor's happy because he has his report. However, you were in a rush, so you did not really give it a good name, or you didn't give it a name at all. And then a couple of weeks later, the boss comes in and asks you for the same thing. And you go, well, I did that once, and then you have to go back and spend more effort. So anytime you're doing something, have the presence of mind to ask yourself, will I ever be asked for this information again? So even if you're in a rush, just be sure that when you're doing something, even if it's in a rush, take your time so you don't wind up having to redo your efforts again. Within the block structure that we talked about, anytime you bring in data, you have to have some area to hold. And we talked about the variables. Now, in the variables, which is the scalar event, that's how you create the placeholder for the information you're going to bring in. And you understand that part of the scalar allows you to have a level of precision in the definition of the item that's going to hold the data. So you have to remember that you're developing this concept of variables and the type. You know, we talked about the big, bigger, biggest, which is really easy to understand. And then I threw the scenario of better, good, better, best. So it's like any language, there are idiosyncrasies that you have to learn to work around. It's conditionals, the if-then scenario, you know, you should have learned that, or that you should learn that concept in other languages, because by the time you get to PL/SQL, you should have had a strong foundation before you get here. So I kind of brushed over it. But understand that that's how you make a decision, or that's how you test information in PL/SQL. You have the if, then you have the else, you have the if, then else, then you have the else if, which is different, and then you have the case. So understand that these are the mechanisms. Now, let me tell you what happened. When I started to do this many years ago, else if and case did not exist. So a lot of the programming I did was basically if then, and then else came in, so I was happy with that. But the else if and the case scenario did not really exist when I started to do this kind of work. And these were new items that were introduced with 9.9 and 10 and some of the, well, actually came in 9.9. Anyway, I learned to program without them. So I had to create a logical structure to mimic this. So I learned how to do the if then else stuff because these tools didn't exist. Now, when these came in, by this time I had kind of risen in the ranks and really never really got proficient on these items. So understand that as you get into programming, you'll become comfortable with the tools that are available to you at the time that you're learning. Understand that as technology advances, there may be other tools that will come into play, and it's up to you whether you feel comfortable with the new or comfortable with the old. Now, the reason I say this is if you build something and then you retire, and then somebody else comes in and tries to do your work, they're going to say, what kind of a nut was this? Because I don't understand this program. Well, you wrote the program in the context of the technology that existed. And I've suffered through that many times when I've taken old programs and tried to convert them to new programs. And you have to understand that those programs were built with the technology of the day, and you kind of have to reverse engineer or try to get that around. So that covers the conditional stuff, the other action. In the conditionals, like in the cursor, when you bring information in, you're going to bring a whole bunch of data in, and then you're going to loop through it. So understand that in this looping process, there is the simple loop, there is the while this condition exists loop, there is for a condition to exist, or the goto. Now, goto has been around forever since programming began, but by today's levels, it's considered, this is a strange word to use, poor programming. So try to get away from using goto. Because what happens when you go to, you're not really finishing an action. You're in the middle of something and then you go, but you're never really finishing what you're doing. And it is possible that if you exit and go to another event in a go-to scenario, since you really haven't finished what you started, that can kind of hang around there. So it's not really a good technique to do it. In some cases it is. Now I'll tell you a scenario that happened to me. Way back when in the year, between 97 and 2000, when they were doing the Y2K scenario, we were in a time crunch to convert old to new, and I came across this piece of code that had some goto in it. Now, the code was functioning right. It was doing the job it was supposed to do. And in order to have expediency, I just copied that information from old to new. It was not good programming, but it was expedient because the code was working, and instead of having to rewrite that code, we just like copy paste. So there are scenarios where it's not good, but if you're in a crunch and you kind of have to do that, I guess you can get away with it. I mean, I got hammered for it later on for not rewriting the code, but at least it was still working. The cursor, remember that the cursor has that looping mechanism. Also, the cursor has the open, has the fetch, and has the close. And then there was two types of cursors, the implicit and the explicit. We really haven't hit on the collections. There's a process called collections that I was going to talk about. When you create a database, you collect information over time. But as you collect it, you organize it, just like alphabetically. So if a doctor opens open for many years, he will collect information for 10 years, but it's always filed alphabetically, so you can sort it. Well, that is how that structure is created in the database itself. Now, when you're doing the PL SQL side, you have to create an organization within PL SQL, and that's the indexing, and that's the collections process. Now that we've got to that point, we now are in a position where we can talk about the procedures that we just talked about recently, the functions, which we talked about recently, and the packages that we talked about recently. So that probably brings up to this point. So now we can proceed with Chapter 8.